we already know what GIS is about. Is about organizing our data into a good way that the system can go into the data, and because the data is organized, it can give us some results like charts or maybe maps, colored map, that once we look at those colored map, we can take a decision uh, in any application. For example, here, I mean, in order to make it very specific to one domain, I think it's better to talk about specific to one domain. So for example, let's say I I'm trying to design a road. Let's say here I have one point A, let's say a city, and then I have another city here. It's called city B. And you want to design a road, and this road it's supposed to join, connect city A and city B. What it takes you to come up with the best design? Okay, you want to come up with one design, which we call it the best design. Now, the best design, it has some criteria. For sure, it needs a kind of a minimum cost, so that's one. And I guess everyone think about the cost, cost. But also, I think you learned somewhere in CBT that it's not only about cost. The question is how this is going to impact the environment, how this is going to impact the wildlife. Okay, so that's why one of the things you have to consider during the design of the road and selecting the route of the road between A and B is where is my wildlife? Where is the forest? Okay, and so on and so forth. And that's why coming up with the best choice of your route for this road, you need to have an access to information coming from different layer or different theme. Now, we're getting into a discussion called thematic layers, because in GIS we said we have a base map, okay? And this base map, it simply contains the geometry, the location, and we add to that some attributes. Those are attributes, we sometimes call them theme. For example, watch this, please. So if you want to come up with the best design of the road between A and B, watch this. Probably, I guess everyone will think about topography, okay? You want to know what are the contour lines in between so I can avoid the bad topography and I can simply get a minimum cut, a minimum fill. Would you agree? What do you think? Would you agree?
Yes.
Perfect. So topography is for sure something that I need to look at and have access to. Now, next is, how about the soil condition? Like, for example, this area, it has clay, and this area, it has sand, and this area has rock. Remember, that even the cut and fill, the price will vary depending on the type of the soil. For example, if I have one area that has rocks, I need to cut in rock. Is that the same price when I cut in sand or cut in clay? What do you think? What do you feel?
Costly.
It is very costly because rock is like concrete, huh? It's very, very hard, and it takes lots of effort to break the rocks. So what does it mean? It means also I need to look at soil condition, because maybe it is good topography. However, when I cut in this area, I will need to cut, which is very expensive. Next is, let's look at wildlife. Let's talk about forestry. What if I'm trying to pick my route here, or the road center line, and I'm going through a forest? Is that good or bad? When you go through the forest, you know what happens, huh? You will simply interrupt the wildlife migration, and that's not really good for the environment. And even look at our 16th Avenue, huh? You guys remember 16th Avenue? Have you traveled west of Calgary and went, for example, to Lake Louise? Anyone? Anyone? Or you guys stay all the time in Calgary? I'm pretty sure that some of you did. Some of you went to Lake Louise, and if I need to remind you, if you go from Calgary to Lake Louise, I think somewhere after Banff, you will see some tunnels, and those tunnels looks like there was a study of wildlife migration, And those tunnels simply they cross. It's a crossing for wildlife from one side of the road to the other side of the road. So this is something you have to think about it and also take it into your cost equation. So forestry, we need to look at where are the forests, and how about the lakes and streams? Do we need to access to the lakes and streams? Like, uh, do we need to know that? Yes, of course, because lakes and streams, we need to know where they are because we have to cross them. If we were to pick one road, we need to cross them. And crossing a lake or a river, it needs a structure, for example, like a culvert or even a bridge. And this will also part of your coast. What if there is existing already bridge? Should I divert my road center line to connect it to the existing bridge so I don't have to build another bridge? Of course, I think this is an option. You just think about it and you see how much does it save you. And then finally, let's talk about property lines. Should I have one map that simply show me the theme of the property line? For example, this area is owned by JC Brown or Rogers or whatever or Adams. Those are very important because remember, if you simply ask to pass through their land, then probably you have to pay them some money, and this will also part of the cost. Really, this discussion is about two things. Number one is in order for you to come up with the best design, which is I would say design is kind of decision, huh? It's kind of decision. So if you want to come up with the best design, you need to look through several layers. Several layers. Look at the name, huh? Layers, huh? And every layer it means it's a map, huh? Every different layer, and every layer will show you some different theme. And the word theme probably corresponds to, for example, theme number one will be the forest topography, lakes, soil condition, and property line. Those are different themes. Now, you need to combine them. For example, when on your design, you say, okay, you know what? I want to pick my road in areas where the ground has mild slope. So you can simply put a limit on the slope. Let's say 1%. Because if you go into soil which has 20 and 30% slope, it means it's not good because simply you will have to have lots of cut and lots of fill. So simply, let's say you want to put one criteria. I want to go on one area that the slope is maximum 1%. Number two, you say, okay, you know what? I don't want to go an area that has clay because clay, I will simply have to kind of replace my soil, and this is very expensive. Maybe I prefer sand. So please go to ask the software to show you the areas where there's no clay. Okay. So anyway, in your design, you should have more criteria. I would say more conditions of what or what not to do in your design, so your design become the best. This is something, by the way, is even experienced or used even before computers. What they do, people, is they show these layers on transparent map. So they draw all those maps on transparent paper and they overlay them on top of each other, where they can say, you know what, this area has good slope, but it is not clay, so I can go there, and so on and so forth. Right now, since we have computers, this overlaying process is not done manually. It is done using the software where you can put some conditions on this for the software to meet. For example, you can tell the software, can you find for me the areas where the maximum slope is 1% and the soil is not clay, and let's say we are maybe 2 kilometers away from the forest. You can incorporate all these conditions in your software, and the software can do the job for you, can predict for you kind of zones where it meets all your conditions. Then you as a designer can refine the selection of the route to come up with the best design within the predicted zone. Now, the thing is, those thematic layers, in this example here, we have 1, 2, 3, 4, 5 layers. 5 layers of different layer of information or different themes. If we change the example from building a road to a different example, I want to, for example, want to pick the location of wind turbine, huh? I want to generate some electricity using wind turbine. I'm asking you, if you have a different application where you want to pick the best location for wind turbine, are you going to use the same kind of thematic layers? Do they have to be 5 all the time? Please ask yourself. The number of layers to come up with the best design or the best decision, you think it has to be always 5? Or sometimes it can be 3 and sometimes it can be 7? What do you think? I think it can it varies. It depends on your application. Also, even the type of the thematic layer, it will change depending on the application. For example, if I need to build a wind turbine, I need to look at map where it shows me the wind intensity in one area. So there are some areas which, for example, if you look at Alberta, in Calgary here, we don't get that wind. But if you go travel to the south, near to Waterton, you will see the wind is very, very strong. So I think the best option is to simply build our wind turbine south on the border with the states. Anyway, so you hopefully get the idea that number one, the number of thematic layers changes from one application to another application, and also the type of the thematic layer will change depending on the application. So here is a few examples of GIS maps. And first thing I want everyone to understand is that what you see on my screen is not a normal map, because a normal map doesn't show you, it shows you only location and geometry. So this is for, I think, for one of the states, and you can see the states that have maybe some urban areas, and you can see here we have so many polygons. Like, let's say this is one polygon here, so this one polygon here and one polygon here, and probably this is maybe corresponds to a different, maybe a subdivision or something. Okay, and so in this map, what are we exactly seeing in this map? Really, to know what you're seeing, you need to look at the legend. So I want everyone to look at the legend here. And so the legend will tell you what do we see on this map. You can see here the legend is about single family dwellings per square kilometer. Okay, and so the if you see a very dark color, it means we have more than 50 single family dwelling per a square kilometer. If you see white, it means less than 10. So it looks like this area, there are some areas here which is maybe super populated. And there's some other area here which is almost white. It means there's not many people living over there. Okay. So this is one example of GIS maps. And again, I want everyone to understand this is not a normal map. A normal map will not show you the single family dwelling per square kilometer. It shows only you the location and geometry only, but it doesn't show you the attributes. So what is the attribute that this map is trying to communicate with me? Is simply this attribute here. Okay, now, for example, what can I use this map for? Let's say this state is trying to build, some schools. Would you build the school in nowhere where there is nobody live? I don't think so, huh? It's not really a wise decision. You simply have to build a school in somewhere where somebody lives. So maybe you can build a school in these areas. So one school here, and one school over there. What if you have a very limited funding, and you can only build 2 schools? What can you do? Probably you can build a school, let's say somewhere here, midway. If the distance is okay, you can build a school here and a school there, where these areas can use these schools, and so on. So you can see here, this is one use of this map. Another map, which probably I will skip because it goes along the same line, it's also about the single family dwelling per square kilometer in different areas. This one is one interesting, and I think we talked about it, huh? We talked about wind speed. So this map here, it doesn't show you the number of single family dwellings in square kilometer, rather than showing you the wind speed. So whenever the color is dark, it means the speed is so high of the wind. Whenever it's white, it means the speed of the wind is so little. Now, how can I use this map in one application? Or who will look for this map? Simply someone is interested to know the wind speed for one application, for example, like building a wind turbine. Okay, so watch this, please. Watch this. So you can see here this area. Obviously, this area here has a dark color. It means the wind is so high in this area. Now you can see it's big area. This probably few hundred square kilometers. Where can I come up with the best design? I need the best design, the location of where is my wind speed. So for example, for sure, I'm looking for wind speed. That's number one. Also, you need to maybe look at the topography. You need to pick one area that has a high elevation. So you need together to read with this map, an area and a map that shows you topography, like where are the high, where is the low. In addition to, you need to look at, for example, land ownership. Is that public land owned by the government or that is private property? So that's why overlaying those three thematic layers will give you the best answer. So when you combine them together, the three of them, so okay, you know what? I'm gonna build my turbine here because that's really the uh, best design, because this will meet those three criteria where I have the highest wind speed, where I have no private land, and also where I have maybe a high elevation. Hopefully you start getting the meaning of GIS, trying to get best out of the available data by just recording those data in a table, and ask someone where should I pick my wind turbine. Nobody knows. But as soon as you turn and create this wonderful product here, you can easily get an informative decision. Now, here is one example of carbon monoxide emission. So here is a road network where I'm showing on different or major roads what is the carbon monoxide emission. Where you see a very dark color, very bold dark color, it means more than 1,000, and you can find this from simply from the legend or the key. Whenever you have more very dark, it means more than 1,000 grams of carbon monoxide emission, until it's very fade, which means you have no carbon monoxide emission. On a major road, since you have lots of trucks, then you can see it's very polluted, while on local roads, there is no much vehicles or trucks, so there is less carbon monoxide emission. This kind of map, maybe what you can do if you have this map, maybe, and you want to solve the problem of the carbon monoxide emission, because that's kind of very bad for the health. Maybe what you can do is you can limit the move of those trucks on this road in a certain time of the day. Maybe you can allow them to maybe drive at night, or maybe you can find a different ring road around the city, something like that. Okay. Now, here is another example of GIS maps, and this is kind of different application. So this is a map for some area in Canada. It's not easy to say that, because I can say that because I know about coordinates. So you can see here we have 50 and 60 and 70. So this is called latitude if you study about latitude and longitude in geography. Okay, so those are latitude, and these numbers like the 180, 160, and 140 and 120, those are the longitude. So simply this area is west of Alberta. This is BC. And BC is close to the ocean, and there is lots of seismic activity close to the ocean. Almost all the earthquakes, they come from the ocean. So you know, we're very far from the ocean, and that's why Calgary is a low seismic zone. But in Vancouver, in BC, in Vancouver, it's like really high seismic zone. And you see this map, it plots squares, and the size of the square, it depends on the magnitude of your earthquake. Okay, you can see here there is 1 all the way to 7, and those Richter scale. And so if you see a big square, it means there is a high seismic activity. If you see small square, it means there is a smaller or less seismic activity. Now, who can use this map? Any thoughts of who can use this map from your study in CVT?
foundation?
Yes, a structural engineer will be very interested to look at these maps because simply once you have lots of activity, it means you have to take a provision in your design to account for seismic because it affects your lateral stability of the building, and you should do something like make a stronger shear wall or maybe make a stronger bracing and so on and so forth. So a structural engineer would look at this map, and it's going to be very useful for the engineer. Now, something I keep discussing, but probably you've never seen it. So you can see here, this is the visual representation of the map. So I'm seeing here a big square, a small square. However, how this is happening? So I'm going to show you right now the secret. So the secret is I have a map that gives me the visual, but also on the background, I do have here database. So for every one of these points here, we have a database. And the database, we store some attributes, and simply the software will reflect these attributes onto your map. For example, look at this. You can see here on this database, I have magnitude of 4.1. And simply this point, if I go back, this point will look this size here, 4.1. And also you see here this number. What are these numbers? Any thoughts of what these numbers are? These numbers are the latitude and longitude. If you don't know what are the latitude and longitude, please wait. Probably in one, I mean, not next class. The next week, I will discuss with you background in geodesy, and you will know what does it mean lat long. For every point on the Earth, it has its own lat long. Okay, latitude longitude. So we'll do that in next week. So you can see here there is one lat long, so I know where is the point, and simply the software will draw a box for me in terms or proportional to the magnitude of my earthquake here. Really, what I want to say is that my map will reflect the data available on the database. Now, I think we're almost there. There's only a couple of slides left for me. I just want to summarize for you. If you want to build a GIS system, let's say you work for the city of Calgary or any other municipality, and they want to build a system for one application. Any application, it could be, for example, road maintenance, any application, okay? And so what are your steps? Those steps are constant. They don't change with the application. Number one is, as we said it before, that any GIS system must start with a base map. Any GIS system will start with a base map. So which means my first step before anything, I will need to capture my spatial data, which is simply, if this name is very difficult for you, please, if you're mute yourself, please. Just creating a bit like background noise, and it's going to be bad in the recording. So the first step is you capture the spatial data, and if you don't like this name, please convert it into map. So I'm referring here to my map. Okay. Number two, we have to store the data, and we talk about data storage in our class because there are so many formats. You can store your data in a vector format or raster format. We have a discussion on that next class. So we have to store the data. Data, they never, ever come free of errors. So one of your steps in building the system is check the errors, make sure that the data is integral, and you clean them from all the errors. And then there are steps called data manipulation, where, for example, you will have to look at things like coordinate system, and merging some data from different sources. So this is called data manipulation. And then we go into get ready, into analysis. So we create some meaningful or do some analysis, and our final results will be displaying our maps and reports. Okay. For example, this one is your last step. Okay, creating this map. Before this step, Remember, what you have to do, you have to go through all these steps, started from data capture, acquiring your map, picking the format of your data, make sure your data is free of error, and then do some manipulation. And I'll talk about this one in details in the next class. Do some analysis, and then finally printing some report for a decision maker. Okay, last slide is something it's called GIS pyramid. GIS pyramid. And what does it mean, GIS pyramid? It simply tells you the different levels of GIS and how many people do work in this level. So GIS we can do data management. We can look at the data, clean them, connect them, merge them together. And then our next step is to do analysis. And finally, the highest level of GIS is called prediction, which I can use my system to predict a phenomena that is happening in the future. Now, in terms of how many people do you work, at the bottom of the pyramid, most of GIS users will work in data management, less they work in analysis, and very less they work in prediction. That is the highest level of GIS. Okay. So what happens here? Time now is I think we have plenty of time, and that's why what I will do is just not really doing anything serious, but I'm going to ask you guys to get ready for next class. And how we get ready for next class, one of them is make sure that you simply have a working software. And how we do that, please watch me. So you go to your start menu. In every CVT student laptop, you will see there is one folder for ArcGIS. Please, before you start, those are based on server license. So the license of the software doesn't exist on your laptop. And that's why make sure on the bottom right here, make sure you have your VPN client running. I'm pretty sure that you guys know what does mean VPN, huh? So make sure that your Global Protect is running. Otherwise, your software will never start. So once you know that your VPN is working or connected, then you go here on all programs, go to folder ArcGIS, and then finally, we will talk about this structure later on. But for now, click on ArcMap because ArcGIS, it has many pieces of software, and we will need ArcMap. So all you have to do is you click on ArcMap, and it will take probably a minute or so until the software is up and running. So as soon as you see your first window, then it means your software is okay. If you get an error message, it means there is a problem with the license. You know what? I'm not sure if I can help you because this is completely an IT issue. And I think I mentioned this already before even the classes started. So if you have a problem with ArcGIS, you want to contact IT, so you give them more time. Here we go. Look at this. So you can see here is my ArcMap. Beautiful. It's working. So if you see it, get this window, congratulations, you're ready for next class. So close this one. Next is, I want everyone to get some data from D2L. Okay, some data from D2L. So really, the data is available on D2L. I already published all the PowerPoint presentation, everything until the end of the year. So everything right now is available on D2L. Please go to module 6. So you can see here that's module number 5, LiDAR. We finished that already. And let's go to module 6. When you click on module number 6, see what happens here. We have some PowerPoint presentation. So please go ahead and download them. This one is the one that we covered today, M6-1N. So we covered this one. We little bit of theory here. We'll talk about it in the next few sessions. And you also download those because those are agenda for ArcMap training. It will tell you what are we going to cover, kind of small agenda. But really what's important is this part here. So you can see there's a folder called GIS data under module number 6. So under module number 6, there is one folder called GIS data, and there is here a zip file. This zip file called GIS-1. You go ahead and download, and then once you download, remember it's a zip file. It means it's compressed. And please just unzip them where you like. I recommend you to create a folder under surveying for our GIS training. So this folder here, it contains the data that we will train you on it next class. Now, any question before we finish today's lecture? Very quiet. Typically, I get someone interested and has many questions, but it looks like not many today. Okay, good. Kitan, go ahead.
Yeah, for the software, do we need to save the file on desktop or like we can save it anywhere after
You
we
can
got?
you can save it anywhere. I personally hate the desktop because if some people they have the habit of copying everything to the desktop, and you will see this the desktop is simply full of files and it's kind of not usable. I would myself will create a subfolder under my survey. Probably you have one already surveying folder. Do you have a surveying folder that
Yeah,
contains all the material? Please
yeah,
create a folder called GIS or ArcGIS training and simply create another folder below called session one or whatever, and then copy all the data, the zip file, and then simply decompress under this folder. It's easier to go this way.
yeah. I have that, but like for the estimating, like we are using one software, like that we need to save it on desktop. That's why.
Okay, thank you so much. In ArcMap, you will see you can read from anywhere as long as you create folder connection, which this is something you will see next class, huh? But it's for your question, please put it anywhere you like, anywhere you like. Now, one thing I want to mention before I let you guys go is that uh, I'm teaching two cohorts. Like you guys are construction management, and the other cohort is municipal. They have 2 days off. Bad luck. The classes is on Monday and Friday, and you guys know what happens soon, huh? So soon we will have the Good Friday and Easter Monday, and they won't have any classes. And that's why it's for them there is enough time to finish the course, enough time for them. For you, you have 2 extra classes. And this what this means, it means you guys will have at the end, before your final exam, you will have 1 full week without any surveying classes. Is that good news?
Yes.
Oh, okay, great. Okay, thank you so much. We'll see you guys on Tuesday. Have a wonderful weekend.
You as well.